secrets, no secrets.
See how to solve these important problems on chemical equilibrium. Yes, they are very important. Question number 1. Calculate the equilibrium constant at 30 degrees Celsius if change in G is, which we call free Gibbs energy, is minus 11 kilojoules per mole. Now, look at how to solve it. You have to tell them that I know this formula that says change in G is equal to minus RT ln K. And we are looking for K, that is called the equilibrium constant. First of all, convert your temperature to Kelvin, because the SI unit of temperature is degree Kelvin. Oh yeah, how do you do it? Add 273 to 30. 273 plus 30. That will be giving us 303. Are you getting it? Then our R is constant 8.314, right? Yes, please, this R is constant. I'm not the one that discovered it, okay? It's constant. Then this change in G is given to be this. Change in G is equals to minus 11 kilojoules. That means it is equal to minus 11,000 joule per mole. That is about change in G, so to speak. Now, we have to make ln K subject of what? Formula. How can we make ln K subject of formula? We say ln K is equals to, come here, change in G all over minus RT. Now, if you are removing ln from one side of the equation, opposite of ln is exponential. That E you know. We say I'm removing ln. I'll be having what? Exponential. Because I remove ln from the other side of the equation. Are you getting it? I will be putting exponential at the other side. Exponential raised to the power of change in G all over minus RT. Now, in mathematics, exponential is equivalent to 2.718. Okay, equals to 2.718. Raised to power of, anytime you see 2.718, it means exponential. It simply means what? Exponential, okay? Now, what is our change in G? We'll have it to be minus 11,000. Minus 11,000 is our change in G. Then what is our R? We say all over minus R is 8.314 times, what is our temperature? 303. So we have to simplify this. So it's better you use your functional calculator to sort it out. Okay, this is my own. Open bracket 2.718 raised to power of bracket 11,000. I will close the first bracket. Okay, minus 11,000. I will close the first bracket. Then I will now say divided by bracket. The second is minus 8.314 times 303. I will now close it. I will press equals to. So if you use your calculator to simplify your own, you will be having K equals to 78.74. That is your answer. Please use your calculator to confirm this we solved and tell me in the comment box if we are correct. Thank you. To answer question number 2, for a reaction to occur spontaneously, delta H of the reaction must be dash. The answer is negative. It must be negative. Why did I answer negative? In the introduction of this topic, I said it that for a reaction to be spontaneous, that change in G must be less than 0. I explained it. I also said that change in S should be greater than 0. Change in S is degree of disorderliness, entropy change, that is the degree of disorderliness, it must be having high degree of disorderliness, and you will require little or no energy applied. That is what we mean by this. Then we also said that for this one, the care should be greater than 1. The care should be greater than 1, and change in H should be equals to negative. That is less than 0. Change in H should be less than 0, care greater than 1. We call this the equilibrium constant, and call this entropy change greater than 0 and this. That means we explain and we said if you want to throw something from up to down, now if I release it, I don't need to start pushing it down like this. No, I'll just release it. It will occur naturally. It will fall down. Bah. That means every spontaneous reaction is called a natural process. It's something that occurs naturally. Are you getting it? So it will fall without the help of any energy being applied. That is meant by this less than 0. And as it's falling, it will fall anyhow. If this is a harmful object, it will fall and destroy a lot of things because it will not have a control. But when we say that something is non-spontaneous is opposite of spontaneous. It means that this one should be greater than 0. You must apply energy. That is what we mean by this. You must apply energy. That means if I have something like matter like this and I want to push it up, I need energy to be applied to push it up. True or false? Yes. Even if it's coming from witchcraft, anyone, juju, it is a force that you are applying. Are you getting it? And when you apply the force and it causes a body to move towards or cover a certain distance, if you apply a force on an object and it moves that object to cover a certain distance, a work is done. Energy has been done or has been applied. That means force times distance. We talked about it before now. Yes, it means I apply energy to push this up. So you see me pushing it up now, it's because I chop better eba now. You understand? So I have energy to push it up. Okay. Now, in this case, we also say that entropy change will be very low. That means the degree of disorderliness of it will be very low. You see me, I'm controlling it now. It can't fall anyhow. You see me, I'm pushing it up. It can't fall anyhow. So the entropy change is low. Are you getting it? And we also say that this should be less than 1. The equilibrium constant should be less than 1, and the enthalpy change, the heat of the reaction, should be what? Greater than what? 0. So this is for non-spontaneity of a reaction. Why this one is for the spontaneous aspect. Are you getting it? Please don't mix it up. It's self-explained. Okay? We go to question number 3. In question number 3, we are given this reaction and we are asked to get the K of the constant, the equilibrium constant of the concentration. Are you getting it? The equilibrium constant of the concentration, given that equilibrium constant of partial pressure is this, this, and this. 1/8 here. This is the pressure, the total pressure given. This is the temperature in Kelvin. And this is the equilibrium constant of the partial pressure. Are you getting it? Now, if you are given this type of question, it is simple. You tell them that I remember that Kp is equals to Kc RT raised to power of change in N. Are you getting it? We have this formula. Now, what is your Kp? Kp was given to be 0.157. What is your R? We say it's 8.314. It's constant. It's always constant. T is equal to 300 degree Kelvin. That is our T. And we are looking for, okay, change in N. Wow. I've talked about this. This is in gas. This is in gas. The change in N is equal to 2 minus 1. The mole of this is 1. That number of mole of the product and number of mole of the what? Reactant. Get the total number of mole of the product minus the one of the reactant. Are you getting it? And so we'll be having it to be 2 minus 1 equal to 1. So you put it here. That means My Kc, making it subject of formula, what is my Kp? 0.157 all over RT raised to power this 8.314 times 300 all raised to power of 1 because their power is 1. Okay, I will go by my calculator again. Divided by bracket 8.314 times 300. I am getting 6.3 times 10 raised to power of minus 5. Please use your own calculator and compute your own. Let's see what you get in the comment box. Okay? Now to solve question number 4. Calculate the Kc for the reaction of this if the Kc of this is this at 500 degree Kelvin. This is when you apply those principles we talk about in the introduction part of this video. What do we mean? They gave us the Kc of this. That means the Kc of this is this. How is this related with this equation? How is this equation that they gave us the Kc, how is it related with the first one? Do you notice that when you carry 2 to multiply this, you have 2. When you carry 2 to multiply this, you have 2. When you carry this to multiply this, you have O2. That means our first equation, the Kc of the first equation can be gotten by multiplying. That means, look at this one, we are looking for this. Okay, our Kc for the first equation can be gotten by dividing everything here by 2. If you divide this by 2, you have this. Divide this by 2, you have this. Divide it by 2, you have this. That means my new Kc what 2 will be equals to my Kc 1 or raised to power of half, because the number I will get here to get this is by dividing this by what? 2. So 1 over 2 times this will give you what? This. 1 over 2 times this will give me this. 1 over 2 times this will give me this. That is what we mean by when I say A, and we have this to be K1. Then we have any A, any B. I get it. Means when you use any to multiply this, and you use that any to multiply this, the implication is that the K for this one, K will be equal to K1 raised to power of that n. That n you use to multiply. So the n we use to multiply here is half. Half times this, half times this, half times this. So that is why we are raising to power of half. So what do we have here? Our Kc1 is 9.71 times 10 raised to power minus 13. So we will be getting the square root of it, because 1 over 2 as a power. When you have 1 over 2 as a power, it simply means take the square root. Are you getting it? Okay, so that is what we mean. Well, that is what we mean. I've explained this, that this will be raised to power of n, the n you have. So we have gotten the raised power of n, which is half. Half is what we use to multiply. Our n is replaced with half now. So that half as a power simply means square root. Now, square root of this, let me use my calculator also. I will now say 9.71 times 10 raised to the power of minus 13. That will be giving me that the answer is Kc2 equals to 9.9 times 10 raised to the power of minus 7. 9.9 times 10 raised to the power of minus 7. That is by approximation. That is for this. Go to question number 5. Now to solve question number 5, calculate the Kc for the reaction this if the Kc of this is this. If you notice from these two reactions, you notice that this one move forward like this, while this second reaction is this moving backward. This move like this. For the second reaction, this one is moving like this. Look at it now. This plus this gave me this. Now for the second one, this is giving me this and this. That means we have come back to the formula we wrote before. A, give me what? B. This is scale 1 and this is scale 2, where we said that scale 1 equals to 1 over scale 2, because this scale 1 is for this and this is for this. So that means they gave us the one of scale 2, the reverse own, for this to go back. They gave us scale 2 and they're asking us to get the scale 1, the one of forward. Now to get the scale 1 from this formula, I will say therefore my scale C1 will be equals to 1 over this what? Second scale C, that is scale C2. 1 over 8. And what is it? 9.71 times 10 raised to power minus 13. Once I compute this, I have done with this. That is why if you understand these principles very well, you will not be wasting your time to solve a question. Let's see. 1 divided by bracket, please package this well. 1 divided by bracket 9.71 times 10 raised to power of what? Minus 13. So that will be giving us KC1 equals to what? 1.03 times 10 raised to power of 12. That becomes the answer. Yes.